Okay. All right, so if I gave you something such as this, well, not such as this is section 5.3. If I asked you y equals radical x, what the heck does that graph look like? Okay, we've never graphed y equals radical x. And we've graphed like y equals x squared. I mean, these right here, y equals x squared. We know that's a parabola. We've been doing those since, geez, about the first day of the school year this year. Y equals x squared. Remember, absolute value graphs are v-shaped graphs. Y equals mx plus b is a line. You guys know a lot of that stuff. Well, what does this thing look like? Well, we're going to do it the long way first, and then this will be the only time that we do it the long way. And then we're going to do very quick rough graphs, okay? So when I plug in values for x, now before you answer this, just look at it for a second. I mean, normally, we say, what can we plug in for x? We say, I can plug in whatever you want, okay? A lot of times we plug in 0, 1, and 2 because those are easy numbers to work with. So do you think I can just plug in whatever I want for x? I mean, and if you might be sitting there going, well, he's asking that, so probably no, but I want to know what kind of numbers you think might be, something you might not want to be able to plug in. Any guesses?
1.
What's that?
1.
1 would be okay. Let's plug in 0. That's 8. He had the guts to speak up. I appreciate that. Okay. Let's start with 0 though. If I plug in 0 for x, the square root of 0 is 0 because 0 times 0 is 0. And we can plug, that was 6. We can plug in 1. The square root of 1 is 1 because 1 times 1 is 1. Nobody knows what kind of numbers you can't plug in?
Negative?
Why? You can't plug in negatives. Why? What's the square root of a negative number? Not a negative number. Remember the last chapter, we spent a whole section on this. Square root of a negative, when you have a negative inside of a radical, it's what?
Oh, an imaginary.
It's an imaginary number. We're not dealing with imaginary numbers right now, okay? So you're not allowed to plug in negative numbers, okay? Because you're going to get imaginary numbers if you put a negative inside of a radical, okay? Now, I could plug in 2. I could. I'm not going to, though, okay? Because the square root of 2, I'm not sure what it is, okay? It's like 1 point something. I could plug in 3. I'm not gonna. I'm gonna plug. You think I'm gonna plug in 4 or not? 4 be a good one? Do we know what radical 4 is? 2. You better. It's 2. Because 2 times 2. Think I'm gonna plug in 5? I could.
6.
Well, what's the square root of 6? Exactly. I'm not gonna plug it in. We're gonna plug in 7? 8? Careful. The square root of 8 is not 4. 9?
Yes.
What's that?
3.
What's the easiest numbers to take the square root of?
Evens.
1, 4, 9, those numbers should look familiar. They might be written on the back of your notebook.
Square.
Squares. The easiest numbers to take the square roots of are squares. What would be the next number I'd plug in after 9? 16. The square root of 16 is 4. Okay? I'm not going to go any farther than that, okay? That's as far as I'm going to go. Okay? I mean, I could plug in 25. And again, could I plug in, for example, 10? Sure, I could. But the square root of 10, I don't know what that is, okay? It's 3 point something, okay? It's not a nice number, okay? So what does this thing look like, okay? I'm not even going to do this last one. I'm only going to do these first 4, okay? So this is not the way we're normally going to do this assignment. We have 0, 0 right here. 1, 1 over 1 up 1. 4, 2 over 3, 4 up 2. And 9, 3 over 9 and up 2, 3, 4, 5, 6, 7, 8. There's 9. 9, 3. This is off by a little bit, okay? So what it looks like if I connected these, I think it looks sort of like, I want to do this dotted part. This is not part of the graph. If I did a mirror image across the x-axis, to me it kind of looks like a sideways half of a sideways parabola, okay? It's the top half of the sideways parabola is what I think it looks like, okay? Now, we've already answered this indirectly. See if you guys caught it, though. I put an arrow here. Should I also put an arrow over here? I'm going to get rid of this part right here. That's not part of the graph. Should I also put an arrow? Should I continue on like this? Is that okay? No, and she already answered it. Because what numbers are we not allowed to plug in? Negatives, and this is -1, -2, -3. You're not going to do that. It starts at 0, okay? So what I want you to get out of this is, what does a radical graph look like? I think it looks like, the way I explain it is, the top half of a sideways parabola. Okay? Any idea what it would look like if I put a negative sign in front of it? It would have been the dotted part right there, been the bottom half of it. Okay? All right.
So you just have to do that, like get all the.
Here's what I want. I'm going to show you what we're going to be doing. I want you to memorize what I just told you. That it looks like, that's what it looks like. Just general. So here's what it is. If I say, what does this look like? You're going to go like this.
Sideways graph.
Okay? Quick rough graph. Now we're going back to September here, okay? Plus 4. Up 4. Same graph. 1, 2, 3, 4. There it is. If it was minus 4, 1, 2, 3, 4, down 4. What if it was this? X plus 4 in
Minus. Left 4.
left 4. Remember, with the x, it's always back and forth, the opposite of what you think. So you go 1, 2, 3, 4. We're just going to move it around. That's all we're going to do. Okay, that's why I told you back in September, I said these little tricks about up 4, down 4, left 4, right 4, that we're going to use it over and over and over throughout this year. That's why that's good. If you memorized it back then, it's a piece of cake. If you're still struggling with it, then you had problems throughout the entire year. Okay, any question on that? There's 2 things, though, that we're going to be learning. We're learning what radical graphs look like. I also want you to know what cube root graphs look like. Okay? All right, now, I don't remember who answered this, but we said the easiest numbers to take the square root of are squares. What's the easiest numbers to take the cube root of? Cubes. So that's the second list that you hopefully wrote down in that notebook. Okay? So, now be careful on this one. Okay? Think about it before you answer. Can I plug in negatives here? Can I take the cube root of a negative? We said a minute ago you can't take the square root of a negative. Jordan said it's imaginary. You can't do that. Can I take the cube root of a negative?
Yes.
Yes, you can. What's the cube root of negative 8? Not positive.
Negative.
Negative what?
2.
Why is it negative 2?
It's 2 times.
Don't say 2.
Negative.
Negative 2 times negative 2 times negative 2 is negative 8. You can take the cube root of a negative, okay? So you plug in whatever you want for x, positive or negative, okay? But we're only going to plug in cubes because cubes are easy. Let's plug in 0. What's the cube root of 0?
0.
0. Because 0 times 0 is 0?
No.
Because 0 times 0 times 0 is 0. Okay? I can plug in whatever I want, we just said. Do I want to plug in 1?
No.
Yeah. What's the cube root of 1? 1. Because 1 times 1 times 1 is 1. I'm also going to plug in negative 1. What's the cube root of negative 1?
Negative.
Negative 1. Because negative 1 times negative 1 times negative 1 is negative 1. I could plug in 2,
2.
but I don't know the cube root of 2. What's the next cube number after 1 on that list of numbers? The next cube is 8. Okay? Because 2 times 2 times 2 is 8. Cube root of 8 is 2. And I'm also going to plug in negative 8, which is negative 2. The next number I would plug in that I'm not going to do because I don't feel like going off the board would be what comes after 8? 27. I don't feel like drawing 27 hash marks, okay? We can get the gist of this graph just by this, okay? So here's what this thing looks like. 8 hash marks in each direction. Up and down a couple. Okay, so 0, 0 is right in the middle. 1, 1 is right 1 up 1. Negative 1 is left 1 down 1. 8, 2 is right 2. I'm sorry, right 8 up 2. Negative 8, negative 2 is back 8 down 2. And it looks like that. Now, should I put arrows on both ends on this one? Can I put on arrows on this one? The last one we said we can't.
Yeah.
Because we can go left and right forever. Now, in my opinion, I think that looks a little more, I've used this phrase before, I call that S-shaped. That, to me, I think that looks kind of like an S. I mean, if you just look straight at it, it's an elongated S, stretched like this direction, okay? I'm just curious. And I've never told you this yet. I'm curious if anybody has an idea. What if it was a negative? What's that? reflected to how? Over what?
The Y.
Who's right? The X or the Y? You both are. Because what it would look like is this. It would go like, if I fold this over the X-axis, that lands here and that lands here. If I reflect it over the Y-axis, this part goes here and that part goes there. So you're both right, okay? So if I have a negative, it just flips it, okay? Or shoot, you can even say it rotated it halfway around. If you spin this thing halfway around, it's back on top of itself, okay? All right, and then again, if I go like this, plus 1, what's that gonna do? Up 1, same graph. And some students have a hard time graphing this thing. Here's what I would suggest you do. If it was up 1, I'd go up 1 and put a dot. And if you have a hard time drawing that thing, go like this. Draw half of a parabola going like this, half a parabola going like that. I think it's easy to graph that. I'm not artistic, but I think that'll do the job. Okay? Any question on these? This hopefully is going to be a really, really simple section. There's one last thing we have to talk about. We'll do that when we actually start the assignment, okay? So, here we go. And again, I'm only going to do 6 of these with you, okay? All right, so what I want you to get out of it, we're not going to do all these table of values, okay? I did that so you know where they're coming from, okay? But here's what I want you to know as of right now, okay? You need to know and have memorized that this looks like that, and this looks like that. That's what I want you to know. That's all we've talked about so far. That's it. And then we're going to slide it around and stretch them out, stuff like that. Okay? So let's look at number 3. 5-3. Okay, they ask us to graph this thing. F of x is x plus 3. Okay, f of x equals radical x plus 3, and the 3 is in the radical. Plus 3 is in the radical. So, let's get very, very basic here. Is this one going to look sort of like graph 1 or graph 2? Or 2 and 1, which is it? 1, why?
Because it's square.
Square root, that's cube root. That's a square root, okay? What's a plus 3 do?
Left.
Left 3. 1, 2, 3. There it is. Problem done. This is why we're going to spend one day on this section. These are going to be really quick ones.
Does it always go like facing the right?
Who's talking? What'd you say?
Does it always go facing the right?
I'm glad you said that, okay? In this assignment, yes. But I'm just curious if you guys can figure this one out. We said that y equals negative radical x would have been the bottom half. What would that equation have to be to go like this? Any idea? Y equals, let me ask you this. You said you can't plug in negative numbers on this. You can't plug in negative numbers on this one, okay? Here, you definitely plugged in negative numbers because it's going to the left.
It has to just be on the outside, doesn't it?
There you go. Y equals, tell me what to write.
Square root of negative x.
In this case, what can't you plug in? You can't plug in positive numbers, because if you plug in positive numbers, this is going to be negative. But if you plug in a negative number, what's a negative number?
Positive.
Positive. And then what would this thing look like? It'd be the bottom half of it. You don't need to worry about that. Good question, but you don't need to worry about that in this class. Okay, let's look at number 5. Okay, all right. F of x equals radical x minus 3. I think that's what it says. So what's this thing going to do?
Move
Right
right.
3. Same graph, 3 right. 1, 2, 3. There it is. Number 7. Okay. Plus 3 minus 3. Got to answer this one in 4 words. What's this thing going to do? Left 3, down 3. Do you have to write left 3, down 3? No, I just did, but you don't need to. So go left 3. Do I put a dot there? Not yet. I still have to go down 3. Put a dot right here, same graph. Okay. All right. I said there's one more thing I have to talk about. Here it is. Okay. Something we have briefly talked about a little bit earlier this year, but not a whole lot. That's my fault. We should have talked about it more. Okay. They want you to graph this, and they want you to do one more thing. X plus 4. x plus 4. Okay, and that plus 4 is outside the radical. Okay? So, let's do a quick rough graph. What's that plus 4 going to do outside the radical? Up 4. Let's go up 4. They ask us for one more thing. What is the domain? There you go.
What's the?
If you remember doing them, you have that response. I hate these, okay? That's like next year, whatever math class you're in. If I say the word factoring, hopefully you go, oh, I hate factoring. That means you remember it, because nobody likes factoring. Okay? Domain and range, okay? In case you forgot what it is. Domain, you look at the graph left and right. Range, you look at it up and down, okay? So, let me ask you this. Does this graph go to the left and right forever? Does it go to the right forever?
Yeah.
How do you know that?
Arrow.
Arrow. Does it go to the left forever? No, it doesn't. What's the farthest over that it gets? And be careful. Some students say, oh, it gets to 4.
0.
But look at the x value, okay? So it's everything to the right of 0. So x has to be bigger than 0. Does it actually get to 0 or not? Can we plug in 0 here? Are we allowed to plug in 0? Yeah, we just can't plug in what numbers? Negatives. So we have to put in equal sign under it, okay? Domain is x is bigger than or equal to 0. Now the range. Don't look at it left and right. Look at it up and down. Now I want to point out here, okay? This looks like it's kind of flatlining. It's not, okay? This is very poorly drawn, okay? It's not just going to the right. As it's going to the right, it's very slowly doing what?
Going down. Or up.
Going up. It's going up. It's still going up. So does it go up forever?
Yeah.
Sure, does it go down forever? No, it doesn't. What's the lowest it gets to?
0.
Not 0. 4. The lowest it gets to is 4. Okay, it goes down, 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 down till it's 4. That's it. So we're talking about everything above 4. So x is bigger than or equal to 4. That's the wrong answer, by the way. Somebody said it. What? Should be y is bigger than. Domain is all about the x. Range is all about the y. Okay? Okay, number 9, number 10 you can do on your own. 19. Okay, 2 more I'm going to do with you guys. Okay, after number 10, we jump all the way to number 19. All the way to number 19. This works out pretty good, too. I'll be done here in about 5 minutes. You guys will have the rest of the hour, and I can finish watching WandaVision. Anybody else watching that? Did you watch today's yet? You know, are you up to date up until today? Today's the finale, you know that, right? I'm halfway through it. It's really good.
You said
It's really good. So keep it down when you're doing your math. I got to watch my TV show.
You said long division.
Huh? WandaVision? Marvel? You know who Vision? You know who he is? And Wanda Maximoff, the Scarlet. Yeah.
I thought you said long division.
No, WandaVision. Okay. So anyhow,
I thought you said long division.
did you? Oh.
It sounded like you said long division, but I knew what you said.
Oh, it's exciting. Oh, watching people do synthetic division. Oh, it's great. So, that's sarcasm. Okay, I'm a math geek, but I ain't that big of a math geek. So. All right, f of x is radical x. Let's write this down. I say that as I'm wearing a math geek shirt right now. This is a gift from a student. You guys remember Spencer Lindsay? Graduated a couple years ago. Spencer got this for me. So, and the coolest thing, I'll share this with you. Okay, the coolest thing about the shirt that he got me, it says on there, math is easy? Yeah, math is easy. And he didn't even realize this, okay? And some of you may not even know this because you don't ever get passes, but if anybody gets a pass from me, you already know this. You guys know how I spell my name?
Yeah.
How do I spell my name? K-O. That's not how I actually spell my name. It just takes too long to write C-A-Y-O. K-O, it only takes half as long. But he got me this shirt, and he didn't even realize this. He got it from Kohl's, okay? Kohl's is spelled K-O-H-L-S. On the ticket, like on the tag, it said at the very top of the ticket, it had a description of the shirt. And on the ticket said this. It said, math is easy. The description of the shirt. And then it was at Kohl's, and it said, the abbreviation was K-O. Math is easy, K-O. Because on this, I can show you the tag. I still have it. I thought that was as cool as the shirt, I thought. So I was like, I don't know. I just thought it was,
That's pretty cool.
I thought it was really cool.
Why are you looking at it? It was meant to be.
I just happened to notice it. It's not like I was looking at it. I pulled the tag off and I looked at it. I was like, that's cool, you know? That's how I spell my name, and it says math is easy. So anyhow, I thought it was neat. X plus 1 plus 8. Okay, so here's what they want you to do. Nothing new here. They want you to describe it, and then they want you to graph it, and that's it. Okay, describe it and graph it. Okay, we've already been doing these, okay? So what's that plus 1 going to do? Left 1 and 1 left, up 8. And then we do that, we go left 1, up. It's going to look sort of like that. 21, last one, okay? I wonder where are the, well, I don't want to say it, let's just go put it up here. Okay, number 21. So we have f of x is this. Something I don't like about this section is they don't give us enough. There's only like 2 questions that are cube root ones, okay? Very likely there's going to be a cube root graph question on your next test that we take in a few weeks, okay? I just wish there was more practice at it, okay? And we'll review when we get to that, so I'll make sure you guys haven't forgotten it. Okay, this one, negative g of x is negative cube root of x minus 1. Okay, I think that's what it says.
Is that outside?
The minus 1's outside. Okay. So, one more thing also. I'm going to take this negative off. I'll just leave it on your paper. But if this was a 2 right here, what would that do to the graph? Stretch it vertically. So, if the original graph looked like this, that 2 would make it look like this. Stretch it out vertically, okay? All right, so keep that in mind. Because you don't have to worry about that in this question, but there is a question that we skipped over that you need to know. Okay, so what's going on here? What does that minus 1 do to the graph? Down 1. We haven't talked about this today. Well, yeah, we did. I take that back. What's that negative going to do to it? Reflect it over the x or the y-axis. I hope they don't. They shouldn't give you both. Is it the? Yeah, they're all x. Good. Okay. So it doesn't matter. Okay. Reflect over the x-axis. Okay. So what I would do is this. I would go down 1, put a dot. And it reflects over the x-axis, so it's not going to go like this, it's going to go like that. So go like this, go like this. Oh, and I will tell you this. It looks, let me see what it actually looks like. What number is this? It's going to be kind of hard to tell. I mean, when you look at the graph, it looks like, it almost looks like it's 2 parabolas, kind of like that. But one of them's red, one of them's blue. I think you can figure it. Are you looking at it right now, Fosmore? Is that how you do? You can tell what it looks like, right? It's not that hard to figure. It's a little confusing, but you can. Okay, questions on this? Okay, you got the hour to work on it, guys. And if you haven't finished up the previous section.